The next important topic is convolutional neural networks. Let's go over the introduction to CNNs. Convolutional neural networks (CNNs) are a class of deep neural networks designed to process and analyze structured grid-like data, such as images. They have revolutionized the field of computer vision and are widely used in tasks such as image classification, object detection, and segmentation. Let's delve deeper into the introduction to CNNs. So let's go over the basic concepts of CNN first. Some of the main key parameters in these concepts are the convolutional layers. Convolutional layers apply convolution operations to input data, extracting features through learnable filters or kernels. These filters capture spatial pattern in the input. Next one is the pooling layers. Pooling layers downsample the feature maps produced by convolutional layers, reducing their spatial dimensions while retaining important information. Common pooling operations include max pooling and average pooling. Activation functions. Non-linear activation functions such as ReLU, rectified linear unit, which we have seen before, are applied after convolutional and pooling layers to introduce non-linearity into the network and enable it to learn complex patterns. Then the last one is fully connected layers. After several convolutional and pooling layers, fully connected layers are added to the network to perform classification or regression based on the learned features. The second topic is convolution operation. The convolution operation involves sliding a filter, also known as a kernel, over the input data and computing the element-wise multiplication between the filter and the corresponding input patch, followed by summation. This process extracts spatial features from the input. Next one is the convolutional layer. A convolutional layer consists of multiple filters that slide over the input data, each producing a feature map by convolving with the input. These feature maps represent different learned patterns or features present in the input. The pooling operations. The pooling layers reduce the spatial dimensions of feature maps by downsampling. Max pooling, for example, selects the maximum value within each pooling window, while average pooling computes the average value. Let's go over the architecture of CNNs. CNN architecture typically consists of alternating convolutional and pooling layers, followed by fully connected layers for classification or regression. Modern architectures such as the VGG, RESTnet, and Inception are deeper and more complex, achieving state-of-art performance on various tasks. How do you train CNNs? So training CNNs are trained using gradient-based optimization algorithms such as stochastic gradient descent, which is SGD, ADAM, or RMS prop, which we saw before. The loss function measures the discrepancy between the predicted outputs and the actual labels, and backpropagation is used to update the network's parameters like weights and biases to minimize the loss. Next, transfer learning. Transfer learning is a common technique in CNNs where pre-trained models trained on a large dataset, example ImageNet, are fine-tuned on smaller datasets or specific tasks. This approach leverages the learned features from pre-trained models and adapts them to the new task, often leading to improved performance with less data. What are the applications of CNN? CNNs have applications in various domains, including image classification, object detection, facial recognition, medical image analysis, autonomous vehicles, and more. They have demonstrated remarkable performance in tasks requiring understanding and processing of visual data. So convolutional neural networks have transformed the field of computer vision and are the cornerstone of many state-of-the-art algorithms for image analysis and understanding. Understanding the fundamental concepts, architecture, and training procedures of CNN is essential for effectively applying them to real-world problems and achieving superior performance in visual tasks. Experimenting with different architectures, hyperparameters, and trained strategies can further enhance the capabilities of CNN for specific applications.